Every year, hundreds of ISTD students must endure the rite of passage in computational structures, designing a hardware game with only pure FPGA goodness. After 12 grueling weeks, Group 1 proudly presents Beat City. Beat City is a game that challenges a player's coordination and reaction speed, where the goal is to try and get the highest score possible. Upon starting the game, colored blocks would progressively appear from the top of the display, increasing the number of lighted blocks displayed. Players would have to clear the bottommost block by pressing the corresponding colored button. If the color of the block is white, they can press any colored button to clear the block. Each successive clear increases the player's score, which increases the game speed, with the slower starting at 0, followed by 10, and 30, and finally 60. Damn, that was fast. However, if the player presses the wrong button, another block would be immediately added to the display as a penalty. The game ends when the number of blocks exceeds the last block of the display, so try not to make any mistakes. By this point, you must be curious about what goes behind the scene to achieve such an elegant and flawless design.
Oh sh**!
Let's take a dive into the design. The most crucial aspect of our game is undoubtedly the LED display. Our major design considerations were wiring the RGB LEDs, which required 4 wires each, and holding each one such that they light up a single block. To ease the soldering process, we made use of strip boards to wire the LEDs, which also served as a piece to be inserted into the mount. To create the effect of a block lighting up, we had to align each LED onto a mount and isolate the light produced into blocks using dividers. This process allowed us to test the game functionality while making it easier for final assembly. The last step was to combine the mount onto the translucent acrylic, and finally the front panel, which gives the desired effect of a tower of lighted blocks. To manage the wires, we used cable ties to bunch the LED wires together, and we also used the strip board to connect all LED grounds to a common ground. Another important hardware component of our game would be the buttons. Each button needs a pull-down circuit to remove residual charges that could mess up the signals going into the FPGA. This was all handled using a strip board to reduce the number of wires needed. Each button's signal is then fed to the FPGA from the strip board with a single colored wire. The buttons would also share a common high and common ground from the FPGA. Since the buttons would face additional abuse due to panicking players, we included additional reinforcements to the structure holding the buttons. Other design consideration includes the FPGA placement. As the brain of our game, all wires from the components would converge to the I/O ports of the FPGA. Thus, we decided to place it at the back of the game where it could be easily accessible. All cable lengths were subsequently determined based on the placement of the FPGA. Once the game functions properly, we can simply cover up the mess with our backplate, which was designed to be easily removable and allows for easy connection to an external power source. The last component of our game is the 7 segment, which displays the user's score. Similarly with the previous components, we used a strip board to ease the soldering process. We also used colored wires to differentiate between the signals the 7 segment needed and labeled each wire for easier connection to the FPGA. Beat City is a simple and addictive game that puts the player's focus and coordination to the test. It can easily bring friends together as they battle it out for the highest score. So what are you waiting for? Get your rhythm flowing and start playing Beat City before Beat City beats you.